Hello, everyone, and welcome back. My name is Dean Cobalt, and you are here to learn more about chemistry. In this video, I am going to be talking about, again, how to use molar mass as a conversion factor. This is the first problem I'm going to go over. I'll do another video with another problem so we get more practice. So here we have a word problem. Again, the way you're going to attack word problems is you pull out the information that gives you a relationship between things, and then that's going to be used as your conversion factors. And then you find the question. The question is going to tell you where to end and where to begin, right? So the beginning of the question, the part that says how many or how much or things like that, that first part of the question, what immediately follows it is usually going to be where you're going to end. And then if you keep reading the question, eventually they'll tell you where to start, or at least they'll point you in that direction. Okay, so here we go. Problem number one. It says an aspirin tablet contains 325 milligrams of acetylsalicylic acid, and they give you the formula, so you don't need to know that or memorize it. So they give you the formula for acetylsalicylic acid, and then they have the question. So we need to write down the information. So they say that one tablet contains this many, this mass of this acid. So one tablet or aspirin tablet, right, is going to give you, is going to be equal to 325 milligrams of this acetylsalicylic acid. I'm just going to say AA, so for acetylsalicylic acid. So that's one relationship, okay? The next thing is the question. So the question will tell you where to begin, where to end. So it says, again, how many? So the beginning of the question is the ending of the calculation, if you want. That's where you're going to be want to end, if that's the way you want to put it. So how many acetylsalicylic acid molecules? Okay, so that's where we need to end. The number of acetylsalicylic acid molecules. So I'm going to put my arrow. So we need to find the number of molecules of acetylsalicylic acid, AA. So where are we going to begin, though? Continue the question. How many acetylsalicylic acid molecules does it contain? What is the it in this question? The it is the aspirin tablet. So they want us to start with the aspirin tablet. So we have one aspirin tablet, so we need to start with one aspirin tablet. Okay, so now we know where to begin. Now we know where to end. We have an equality here that we can use as a conversion factor. And, and we also need, if we're going to molecules and we're starting with aspirin, we know we can convert from one tablet to mass, but we need to get from mass to molecules. And part of that process is we're going to have to use the molar mass to go from mass in grams to moles, and then from moles to particles. So that's the process we need to go through. And so we're going to need molar mass, and they gave us the formula, so you would need to calculate the molar mass. Now, I'm not going to go over how to calculate that. I've gone over that in another video, but at this point, you should know how to calculate the molar mass of any substance if you know the formula. So here's the formula. I already calculated the molar mass as 180.15 grams per mole. So that's another equality. So I know that 180.15 grams of this substance, AA, acetylsalicylic acid, is equal to 1 mole of acetylsalicylic acid. Okay, so we have everything we need. So let's start our conversions. So we're going to start with one aspirin tablet. So I'm going to say 1 tablet, and we're going to put that over 1. Okay, so I need my first conversion. I need to convert tablet to something. So I have an equality with tablet and milligrams. So I'm going to use that to convert to milligrams. So if I have tablet on the top, then I need to put tablet on the bottom. And I have one tablet, and then on the top, I'm going to put 325 milligrams of my acetylsalicylic acid. So remember, I always have 3 things: the number, the unit, the substance. Okay, now the tablets, I should have like tablet of aspirin if I want the substance aspirin, right? Aspirin. Okay, so that's going to cancel out. Now I have milligrams of acetylsalicylic acid. Now, if I want to use my molar mass, grams to moles, I need to get grams. So I need to convert milligrams to grams before I can jump to using molar mass. So let's do that. So I'm going to multiply by another conversion factor. So I need a relation between milligrams and grams. So the way I do this is I set grams equal to milligrams, and I have a space to put numbers. I always put the 1 with the unit that has a prefix. Now, when I have metric to metric, I need to know the prefix multipliers. So if you don't know the prefix multipliers, you got to go back and look them up or memorize them, but you need to know them. So here I have the prefix milli, so this is milligram. So this, I'm going to put a 1 here. That's where I'm going to put the 1. So the 1 goes with the prefix, the unit that has a prefix. And then since this has the milli and this does not, I'm going to put the prefix multiplier with the base unit. I always put it with the base unit. Milli is 10 to the negative 3. So I'm going to put 10 to the negative 3 there. Okay, so now I have my relationship. Now I can convert. So I have milligrams on the top, so I want milligrams on the bottom. So I'm going to put 1 milligram of acetylsalicylic acid on the bottom, and then grams on the top. So 10 to the negative 3 grams of the same substance, acetylsalicylic acid. And then I'm going to cancel out the milligrams. Now I have grams. Great. So now that I have grams, I can use my 1 mole of acetylsalicylic acid to the 180.15 grams of acetylsalicylic acid. Okay, so now I can use a conversion. I'm going to do another conversion factor. I have grams on the top, so I want grams on the bottom. So I'm going to take this grams, 180.15. I have 180.15 grams of the acetylsalicylic acid. And then on top, I'm going to have 1 mole. I'm going to put the 1 mole on top. So 1 mole of the acetylsalicylic acid on top. I'm going to cancel out the grams. Now I have moles of acetylsalicylic acid. So now I can go from moles to molecules. What am I going to use? I'm going to use Avogadro's number. I'm going to use the fact that 1 mole of anything, but in this case we're interested in acetylsalicylic acid, that's going to be equal to 6.022 times 10 to the 23rd molecules. That's our particle. Molecules of acetylsalicylic acid. So now I can use that relationship to convert from moles to particles, in this case molecules. So then, since I have moles on the bottom, or on the top, I'm going to put moles on the bottom. So 1 mole, right? So I have 1 mole of acetylsalicylic acid. And then on top, I'm going to put Avogadro's number, 6.022 times 10 to the 23rd. And that's going to be molecules, not moles, molecules of acetylsalicylic acid. So moles of the acid cancel out. Now I have molecules. The problem is asking for molecules because that's where I need to end. Now I am done. I'm finished with the conversion. So now all I need to do is just multiply everything across the top, divide by the bottom. The ones you don't need to multiply by. So I'm gonna do, okay, so I have 325 multiplied by 1 times 10 to the negative 3 multiplied by 6.022 times 10 to the 23rd. Okay, now I'm going to divide 180 divided by 180.15, and that's a 1, and then equals. And so what I get is, for an answer, right? So my answer is here. I don't have room, so I'll put it here. I get 1.0864, 1.0864, and then I get a bunch of other numbers, 0, 0, 0, 2, 2, whatever, blah, blah, blah. Oops. Times 10 to the 21. And that's going to be molecules of acetylsalicylic acid. Now, we've done our calculation. We set everything up correctly. Everything cancels out correctly except for molecules. And so we should have the right answer. Now we need to worry about significant figures. So we look at the numbers we multiply. Ignore anything that's exact. So remember, if you have a metric to metric relationship involving the same type of measure, right? So mass to mass, length to length, time to time, things like that, then it's going to be exact. If you have English to English, then that's going to be exact. The only time it's not going to be exact is if you are mixing up the measurement. So if you have English to metric, or if you're measuring mass to volume or something like that, that's going to be a measure. Okay, so let's look at what we have exact of. So this is a measure, right? That's not exact, so we need to pay attention here. This is a measure, so molar mass is a measure, so we need to pay attention here. Here we have milligrams to grams. That's metric mass to metric mass, so that's exact. True by definition, so we can ignore that for sig figs. This is a measure, 325 milligrams per tablet, and then we are given 1 tablet. 1 tablet is exact because that's a counting number. So 1, 2, 3, 4, 5, 6 tablets. So we're dealing with 1 tablet, that's exact. So we ignore that. So this has 3 sig figs. This has 5 sig figs, and this has 4. So the least number is 3. So 3 is the number. So we need to cut it off at 3. So this is a 6. We raise that up to a 9. So 1.09 times 10 to the 21 molecules of acetylsalicylic acid. So that would be the answer. Okay, ladies and gentlemen, I hope that was insightful and helpful. That's how you can use a molar mass of a substance to, and as well as Avogadro's number, to convert from mass to particles. You could do the same thing if they ask you to go from particles to mass. You're just going to work backwards, but you're using the same equalities, but you're setting up your conversion factors differently. I hope you enjoyed it. Like the video, subscribe to the channel, share the video, make a comment in the comment section, and I'll see you next time.